Hey guys, this is Mitch with Finepoint CGI, and today we're going to talk about how to integrate Postgre into Godot. So I created a plugin that can actually integrate Postgre into Godot, and we're going to go over that. So we're going to go over how to install it, how to install the plugin, how to activate it, how to work with the plugin, how to do asynchronous queries, how to do transactions, how to roll back your transaction, and really just a lot of database stuff in general. So that's what I have in store for you guys today. So let's go ahead and get started. All right, now the first thing that we need to talk about is what plugin we're going to be using to work with Postgre. So the plugin that I covered, I want to say almost 3 years ago, was PostgreSQL Client by Marzan Bot. And unfortunately, he's archived it and it no longer works with Godot 4.4. So if you're using like 3, you could use this plugin and it would work and you could follow my previous tutorial. But unfortunately, it's been completely overshot by a lot of the Godot changes. So I've gone ahead and built my own plugin. And of course, you guys are more than welcome to put in issues, pull requests, things like that. But I've added a lot of good creature comforts that we can use here. So, I'm not going to go through all of the things, but I have some pretty decent documentation here for you. But a lot of what I have is transactions, rollbacks. I have, asynchronous querying. I have a bunch of signals we can work with, things like that. So I have built a tool that should work pretty well for what we are going to be using it for, at least as it relates to game development or really any type of development applications or things like that. So we're going to be using this plugin. And of course, again, put in PRs, put in issues, let me know if there's anything that you think are missing. So in order to use Postgre, you have to download it. Now, you can use Docker if you want to. I'm installing it, but I'm installing it directly. So let's go to the download button and you guys can go ahead and choose which version. Now, if you're running Linux, use Linux, Mac, Windows, right? I am using Macintosh currently, so I will go ahead and grab that. Unfortunately, I've been traveling so much for work that I've just been using my Mac instead of my desktop. So we're going to be using that for now, and I'm going to be using version 17. Now you can use whatever version you want to. This plugin will work with any version of Postgre. It doesn't matter. Now, how I like to install stuff is via Homebrew, and I highly, highly recommend Homebrew. It's very good at installing stuff. Now, what is Homebrew? This is Homebrew. Homebrew is basically a way for us to be able to install stuff with a command versus just downloading a package and installing it. So if I open up a terminal here and I want to install Homebrew, you just copy this little guy here and paste it. Now, I'm going to not do this because I already have it installed, but this is how you install Homebrew. Now, I will leave a link in the description below so that way you guys can go ahead and download that and use it if you'd like. If not, you can just download the app file right here and it will let you install it. However, it gets kind of funky if you do it that way. Now, to install it via Homebrew, grab this little brew install, paste it, and then let's use the version 17. 17 is the version that I like to use, so we'll go ahead and do that. If you want to use version 13, 12, 16, it doesn't really matter as accordance to the plugin, but I always like to use the newest version. It has the most up-to-date stuff. It has lots of optimizations, bug fixes, things like that. So we'll go ahead and hit enter and install that. Now, I already have it installed. You can see it's already installed and up to date, but if you do that, it will go ahead and install Homebrew. Now, the other tool that you should install is PGAdmin, and PGAdmin is an awesome tool. It's basically the standard when it comes to interacting with Postgre databases. It is their administrative tool that can give you all sorts of instructions and things like that on how to set up metrics and things like that when it comes to your database, and it lets you select data, create databases, things like that. So it's basically the standard when it comes to the tool. We're going to go ahead and download that. So download. And you'll see that they have different versions. Now, of course, if you want to use Docker, like I said before, you guys can. In my case, I'm just going to click on Mac and we'll go ahead and install that. So we'll click on PGAdmin 9.4, click, and then click on whichever version you want. So if you have an Intel Mac, you would use this one. If you have a ARM Mac, you would use this one. So I'll click on ARM and then we'll go ahead and download it. So now that I have it downloaded, we'll double click on pgadmin94, hit agree, and it will go ahead and verify and install it. And as with most Macs, just drag it over and it will install. And now that we have it installed, let's go ahead and start our Postgre service. So I'm going to open up our terminal and I will type brew services start PostgreSQL. And that should, and we'll type brew services start PostgreSQL at 17, because that's the version we're running. Now I'm already running this, so it's going to say, hey, this thing already exists, but that is how you get that thing to kick off. So now we can actually test our stuff. So if we hit Command Space and open up our pgadmin4, you will see here that it's going to boot up pgadmin. And I'm going to go ahead and click Allow. Now you'll see here it says, hey, do you want to add a server? So you can see right here this little quick link. And for those of you who are dark mode people like myself, if you just go to the preferences, then I believe it's under miscellaneous user interface, there should be a theme right here. Let's change that to dark and get light mode out of here. So you can see here we have different workspaces, and that's totally fine, but most of the time you're not going to be using those anyway. This is your Object Explorer. So you can see it's trying to connect to my PostgreSQL server. Let me remove that really quick so I can actually show you guys how that works. You can see this is where all your servers will be. This is your properties, which is your properties for your database. This is where you can execute SQL. This is your statistics, dependencies, dependents, and processes. These are all things that you have no need to actually know anything about, at least as of right now. But as you grow as a person that uses databases, you'll have to learn about these things. So we'll click on our dashboard. We'll click on Add New Server, and you'll see it has a name. So in my case, I'll just call it Tutorial Server. I'm going to go to Connection, and I'm going to say Local Host, and we'll grab port 5432. And for the username, let's go ahead and use our name. So whatever your name is, whatever your username is whatever this is. Now that might be Mac specific. A lot of times it's just Postgre on other platforms, but on Mac specifically, it's going to be whatever your username is. So we'll say find.cgi and we will hit save. And you'll see that we are now connected to our server, just like that. And there is our first little database, and then here's our logins right here. You can see find.cgi was already created when I did my brew install. Now you might not have that, it just kind of depends, but in my case, I do. So once you have the setup, you should be good to go. So now we'll head back to our web browser here, and we'll head back to our plugin. Now I have already packaged a release for this plugin. It is right here. We'll go ahead and click on that. And we'll go ahead and pull down that zip right here. But you can see I already have it pulled down. So I'll hit save. So it will go ahead and download it. And then I will head out to my downloads folder. And you will see I have it up here. I'm going to double click that, and that should open it up into my tutorial downloads folder. And you can see here is the contents of that plugin. Now I'm going to change this to as list so you guys can actually see stuff a little bit better, because naturally Mac always makes things a little bit difficult. So what we can do here is we can extract either the tar.gz or the zip. tar.gz is for Linux, zip is for Windows, more or less. And if you have a Mac, you can do either one of them. So we'll double click on the zip, and that will extract it here. And you can see here is our plugin. Now, when you're doing your plugin, you can use the demo if you would like. That has everything already pretty much set up other than the bin folder. You'll need to replace this. It does have a version of the adapters put in here, but you don't have to do that. In this case, we're going to go into the bin folder. We'll pull this Postgre bin folder and the Postgre adapter. Now we're going to open up Godot here. So go ahead and open up Godot and create a project. Now I'm going to right click, open in File Manager, and then I will go ahead and drag these guys into my project like that. I'm going to click, and it should attempt to open it. Now if you have a Macintosh, it will get mad and say, hey, we're not going to open this because we don't know if it's safe. So what I highly recommend, or I guess the way to solve that, is to hit done, 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 Done. Click on this little Mac icon, go to System Settings, go down to Privacy and Security, and then scroll down to the bottom and then hit Allow Anyway. And then when you click, it's going to come in and say, hey, we cannot verify that this is a real thing. Hit OK, open anyway, and then put in your password, and now it should load. Mac is very big on security, and they get really upset about these types of plugins. So just keep that in mind. So now we can click on 2D Scene, right click, add a child node, and if we take a look, there should be a node in here called PostgreSQL. That is the plugin. That is the actual plugin for us to use. So we can double click that, and you can see right here in our inspector nodes, you can see we have all of these signals. If you have all those signals, you've done everything correct and you're good to go. So once we have this, we should be good to go. So let's right click our node 2D and let's attach a script, and let's just call this database interaction tutorial, like that. And you'll see here we have a ready and a process, much like most Godot nodes. Now, first things first, we need to get a reference to our Postgre adapter. So I'll say on ready var Postgre adapter is equal to $Postgre adapter. And it's going to pull back that Postgre adapter. And if you want to type it, you can. It's up to you. So you could do Postgre adapter like that, and that would get you auto completion and things like that. So that's something to keep in mind. Now, first things first, we could connect all of our signals if we want to, and I'm going to go ahead and do that real quick because there are a bunch of them. So we're going to go ahead and connect to our database. So we'll say PostgreAdapter dot connection string is equal to quote, and you can come up with whatever kind of connection string you want. In my case, I have my PG admin. You can see I have find.cgi as here, and if we go to properties on this, you can take a look at my definition, and you'll see that we have a password. So we'll put a password on it, and in my case, I'm going to put password as my password. So password, and we'll click save. And that's just going to set this as having a password because we don't want to not have a password on our user account. So I'll add that in, and then we'll head back here and say PostgreSQL //find.cgi. This is your username, password, which is your password, at, and then you have to put your address. So if you're hosting this out on a network, or if you're hosting this out on the internet, you have to put the proper IP address. In my case, it's localhost. And then we'll do :5432, which is the port I'm currently using. And now we need to point it to a database. So if you're going to make this into, multiple databases or something like that, you'll want to parameterize this. But in our case, we'll just do Postgre. I believe that is the database right there. And there we go. And now we can come in here and actually connect to our stuff. Now I'm going to step in and I'm going to teach you guys a little bit about this plugin. So by default, we create a connection pool. And a connection pool is a set of connections to that database that helps keep our stuff efficient. So think of it kind of like this. When you have a connection pool, it basically says I have, in my case, by default, I set this plugin to have 4 connection pools. So you have 4 connections at all times. So that means you could have 4 simultaneous connections to the database and do stuff in 4 separate connections. 99% of the time, you're not going to use all of that, but I wanted to make sure that it was scalable. So that way, if you're building a giant enterprise application, you can do that. So what happens is it pulls one of the connections, it does its operator, and then it releases that connection. And then the next time it pulls a connection, right, it does a thing, and then it releases that connection. So if you have 2 things that are trying to do stuff at the same time, it's not waiting to create that connection. It's already there. It reduces that latency by a lot. So that's what it's for. So by default, I have my connection pools set to 4. You can set it to whatever you want. And you can do that by going PostgreAdapter.setConnection, set pool size, and you can set it to something like 6. And that would set your actual connection pool to 6. Now, of course, this is really in-depth stuff, and this has nothing to do with what the basics of this plugin is, but just know that that is a thing. Now, in my case, it's defaulted to 4, and you can, of course, pull that if you need to by saying get underscore pool underscore size, and that will pull back how many connection pools you have. Now, again, not necessary for this tutorial, but I just wanted to make sure that you guys had that understanding. Now, by default, it is 4, so there, that is that. But what this code up here does is it just sets our connection string. Now we need to connect to our database. So if PostgreAdapter.connect to DB, and this is a true false, so it will return whether or not it connected to the DB. So when you hit connect to DB, it says connect to the database, right? If it fails, it will come back with a fail, right? It'll come back with a false. So we can just say else failed to connect to the database. And I probably should set up a way to return some kind of error code or something like that. That way we have some stuff. But that's for here. That's for later. So we'll come in here and we will say if we connect to database, then let's go ahead and do our basic setup. So first things first, we need to create a table. So let's go var create user table, and we'll make that equal to, and I'm going to go with 3 equals quotes, and that's going to give me the ability to hit enter and work through my stuff. So inside of SQL, you want to create a table. So create table if not exists users, and we can pass in values. So I'm going to create table if not exists ID serial primary key comma name varchar, and I'll make that something like 100, let's say, not null. That's going to basically make it so that we cannot have a null value in that. And then I'm going to put something like level, and I'll make that into an int. Email varchar, we'll make that 200. Active boolean default true, and then created at timestamp default current timestamp. Now you're going to see this and go, I have no idea what you're doing. Or maybe you do. I don't know how much you know about SQL. So let's take a step back. So since this is something that's going to be running on startup, I have create table if not exists. This basically says, look, if this table doesn't currently exist, create it. Simple enough. And the table name is users. Now I'm using underscore users, lower a non-capital users. It's just the way that I do it. If you want to use capital users, you can. I have ID, which is a serial. What is a serial? It is a auto incrementing integer. So you can see serial just means anytime something gets put in, it's going to auto increment. It is a primary key. So what this means is I have an ID value that's going to help me with joining tables later. And again, I understand you might not know enough about SQL to know what that means. And don't worry, we'll get to that. But this basically just increments. Anytime data gets put into the database, it's going to increment. So from 0 to 1, 1 to 2, 2 to 3, right? And that way we have a unique identifier for that user. I understand we have a name, but trust me, names are very slow. So just keep that in mind. Now you'll notice that I have name, right, and it's not null. This means that the database will throw a exception if you pass in a null value for name. So that's something to keep in mind. Now you can see it's a varchar. Varchar is variable char, which is basically a number of letters that is associated with a string, basically. So a char becomes a string when you have multiples of them. So this is saying that I have a variable, which is a char, and it allows for 100. So that means the max size of a username, and technically we could make this user name, and the varchar means that they can have up to 100 characters. So you'll notice that a lot of times games only allow you like 100 characters or 20 characters or whatever that happens to be. That's what a varchar 100 is. The reason why we do 100 is because we're scoping the size of that column to be smaller. And that helps with data efficiency. It's very important to scope your data to be exactly the size that you want, or at least within a small parameter of what you want. Level, which is an integer. Email, which is once again a varchar. We had that conversation. And you can see here we have a Boolean default true. So whether or not they're active, a Boolean is 1 or 0, right? Active or not. And we're defaulting it to true. So we're saying, hey, if I insert data into this database table and I don't supply an active value, it's going to just assume that you are active and then create it at. And you can see that this is a capital A. You could go create it underscore at, like so, if you want to. That's up to you. It's dealer's choice. Timestamp, which is a type, so it's going to be a timestamp. So it'll be a date plus time. And then the default is current timestamp. So if we insert into the database by default, or at least into this table, by default, it will be the current timestamp. So whatever the time is that it got inserted. This is really useful because then you know when that row was created. And that's basically all you need to know. Now I'm also going to come in here and create another table real quick. So I'll just grab this bit of code here and paste it and then say create character table. And I will say create table if not exists. We'll just copy that, paste, create table if not exists, and we will do a characters table. Now inside of the characters table, I'm going to once again create an ID. You always want an ID column. It's this very important to always have that. And then what we can do is we can have player name varchar, and we will give them a 100 because let's assume that they have multiple characters, right? And we'll make that not null. And also you'll notice that this isn't capitalized and this is, it doesn't matter. SQL does not care about capitalization, so it should be good. And actually, really, now that we're looking at it, we could, and now we need to link it back to this table. So I will say user ID or users ID. I always like to do the table name followed by their column. So you can see users ID, ID, like that. And then I will do int references users ID, like that. And then I will pass in its health, which is an int, level, which is an int, and inventory. And we'll pass in an inventory ID. We'll pass in an int, and then we will do a references. And I missed an E in here, so ENCES. We'll reference, and then we're going to reference a table called inventory, like that. And I'll pass in ID. Now, you'll notice that me doing this is going to cause a major problem. So we'll get to that in a minute. I'm going to do close, semicolon, and then 3. Now, we'll come up here and we'll make one more because you can see I am referencing my inventory. I don't have a table called inventory. Let me just copy this and let's create one. We'll come in here, copy, paste, create inventory table. And then we'll say create if not exists, inventory. We'll pass in an ID. We'll say type. We'll make that into an integer. We'll say name. We'll make that into a varchar 200. And from there, we can have different statistics and things like that. But in this case, we'll just leave it here for now. And this will basically set up a nice little table structure for us to do our testing. So now if we want to actually execute code using our PostgreSQL adapter, we can go ahead and type PostgreSQL adapter dot execute non-query, and we can pass in our string. So we can pass in create user table, like that. And then I'm going to duplicate that 2 more times. I'm going to do create inventory table, and then I'm going to do create character table. And now, in theory, providing nothing breaks, which God knows it's going to, we will click play and see what happens. So let's hit Control S, save our Node2D scene, and hit play. Now you'll see that we have an exception here. Exception creating construction, connection to server localhost, port 5432 failed, PostgreSQL does not exist. So let's pause this really quick and let's take a look at it. I think I might have found the issue. So the database is Postgres, not PostgreSQL. I missed the S on the end, so let's try that one more time. We'll fire it off and you will see that you get connection acquired from pool size is 3, attempted non-query, retry 0. It gives you some debug statements, that way we know, and then it says that it executed successfully. And then the connection was released from the pool. And you can say we get multiple of these, so don't worry about it, but Basically, this is my way of giving you guys a nice debug to explain where things are in the code in case you need it. Now, that being said, maybe I should rip these out so that way you're not reading all my debug statements, but that's neither here nor there, so that might get ripped out before this tutorial publishes, but still, it is there for right now. Now, if we take a look, if we stop our little project here, we take a look at our PG admin, you can see we have a big spike in activity here. And if we head to our tables, which is under schemas and then tables, you can see we now have 3 tables, and these 3 tables have our schema as we expect. So if we looked at our columns, ID, user ID, right? Health ID, or level, inventory, right? So we have all of our stuff set up. So that's basically how you interact with our database. Awesome, right? Nice and simple. So now the question is, okay, that's really cool, right? Now I can do connections. If I run this a second time, what happens? If I hit play, it works just fine. It says it successfully ran, didn't affect anything, and you're good to go. So just know that you can rerun this even though it's creating the database. It doesn't matter. If you don't want to create your tables like this, you don't have to. You could do it inside of PostgreSQL, but for this tutorial, this is how we're going to do it. So now the question is, all right, what else can we do here? Well, we can actually come in and do what's called a parameterized query. And a parameterized query allows you to do things in a very safe way. And what I mean by that is a lot of times when you do something like this, it can be SQL injected. So think of it kind of like, I'm going to bypass your SQL and I'm going to inject data into your database. So a lot of times what people will do is they'll come in and they'll run, let's create a quick SQL statement here. So var insert user, right? Query like this, whoops, Q, not A, is equal to quote insert into users name, comma, age, comma, email, comma, username, comma, level, comma, email, comma, and that should actually be it because by default their active is true. And then you could say values, and you could pass in something like, let's say you come up here and say var name is equal to test, var level is equal to 1, and then email test@gmail.com. Then you could pass this in and do something like this, right? Plus your name plus quote, comma, plus level, right? Just like that, right? Well, this is how you would do a non-parameterized query. And the reason why this is a problem is because while this would execute correctly, right? If somebody came in and bypassed it by doing something like little quotes like this, and then drop table users, that could allow them to completely wipe our database. And that's a huge problem. And that's where parameterized queries come in. So how do we handle a parameterized query? Well, what we can do is we can come in here and say values $1, $2, $3, like that, returning ID, like that. And that's just going to return the ID. That way we can actually just return that specific ID value when it's done. This is just me being a bit more, crazy with my SQL, but that just allows me to return that selected value. It's just because I would like to have it for future use in the tutorial. So we'll insert that data, and then to execute it, all you have to do is you go var arms is equal to bracket quote, and then you can come in here and insert your data. So the username is going to be test1, the level is going to be 1, and the email will be test1@gmail.com. And then I can duplicate this, say parms2, parms3, test2, test3, test2, test3, and then we'll change this guy to level 10 and level 15 respectively. And then in order to execute a parameterized query, it's the exact same thing as executing a non-query, except for we do execute query. So we say var user1 result is equal to postgre adapter dot execute query, And you can see I have a parameters section. So we'll execute our query. So insert user query, comma, and then parms, like that. And the nice thing is I can duplicate this and go parms1 and parms2. And then I can come in here and say user2, user3, and I've already updated all of my stuff. And it's nice and quick. And actually this is 2 and this is 3. So that way I can actually insert that data. Now, if we hit play, you'll see that it's going to execute it. It says, hey, we actually have a syntax error. So that's not a good thing. So let's take a look as to why. So you can see right here in syntax error near returning. Let's take a look. I probably spelled returning wrong because capital letters kill me. returning. And okay, let's try that. Let's refresh. And you can see that the query was successful. And now if we take a look at our Postgre database, you'll see once again we have a spike in work. And if we take a look at our data in here, so if you come in here, right click, you can come in and view the first 100 rows. And you should see it's going to select the data on that users table. And you should see that we have our users inside of that database. And that's all we really need to do. And you can see they actually have a primary key as well. And the cool thing is that this also inserted that data into my database. Whoops. This inserted the data in my database. And that's how a parameterized query works, is you can actually do this and make it a bit safer. It allows you to go in and make adjustments into your queries and do checking and things like that in a much safer environment. Now, this also works, of course, with selection statements and things like that. And in order to show that off, I'm going to do what's called a transaction. I'm going to show off the next part. This is how you do a parameterized query. So if you ever want to do one, you could always just, let's take these two, for example, copy, paste, and we could say select star from users where, and I will pull all of this is out, and I will say where, and the username equals, and then we can go $1, and then we can just come in here and say test1. So, and then I can print that result. Postgre adapter.execute non-query, and we will pass in our, in this case, it's insert user, so we'll just say select users and params, I guess 4 in this case, and we'll pass in the select user query, comma, params 4, like that. And now, in theory, if we refresh, this should give me the data right here. So you can see right here is our returned data, and it has selected the data as we expect. We got ID 1 and ID 4. You might be wondering, well, hold on, why did we get ID 1 and 4? That's because up here we're inserting data. So I've inserted double the amount of data. If I actually select star once again and I hit play, you'll see I have now double the amount. And the reason why is because we've ran this twice. So therefore it's going to double. And that's where we can clean this up by just deleting the data from the database. So that way we actually can, test this out. So we'll say Postgre adapter.execute non-query, quote, delete from users, like that. And that will just delete that data. So if we hit refresh, you'll see that it's going to run. And then you can see here, if I look at my database and I select star, you'll see that all that data got deleted. So that's a way that we can clean it up while we're working from here. Now, once we have this, what are some other really useful features? Like this is basically 90% of the adapter. So if you only need this, there you go. You have everything that you need. But now let's get into some of the weird stuff. What about transactions? What about asynchronous queries, right? What about those types of things? Well, that's where our transactions come in. So we have a way to do transaction support in here. So how we can do it? I guess let's take a step back. What is a transaction? So a transaction is a way to do multiple SQL queries on a database and then write it all at once. And you might be wondering, okay, what's the purpose? Well, think about it this way. Let's say we're updating a user's inventory, right? We have 50,000 items that we want to update. doing it inside of a regular for loop, right, where we say for each item in the user's inventory, go ahead and update that data every time we have to create that connection. And that connection has a lot of overhead, right? Whereas this way, we can actually go in and update all of those rows all at once and make that transaction work for us. So in order to do a transaction, all we have to do is come in here, and first I'm going to hide that so it doesn't delete from users, because I'm going to be doing some other database related things. So I don't really want to mess with that. But what we can do is we can start a transaction. So in order to start a transaction, we could just say var trans started is equal to PostgreAdapter dot begin transaction. And then we'll say if trans started, then let's go do our stuff. Now, a transaction, like I said, holds onto the database. So you don't want to hold onto it too long, but it's for bulk operations. So what I'm going to do is I'm going to come in here. And if I remember correctly from my data structure here, I have a character section. I have an inventory section. You can see that the user can have multiple characters, and the characters can have lots of inventory items, right? So what we can do, and actually I'm looking at this and I don't like this. I think what I need to do, I'm going to need to make adjustments to this. So I'll probably have to drop this table, because now I'm looking at this, and right now the only way for this to work is for the user. He has a reference to an inventory, but he doesn't have a reference to objects, and that could be a problem. I feel like I'm going to need to make a linking table between the two, so that way I can have the inventory items. Yeah, I would have to flip this. This will need to be flipped. This is my fault. I made a mistake here. So this needs to have the character ID references characters ID, like that. We actually need to flip that relationship. So we'll need to drop our database and recreate it, which is a big unfortunate side effect of this sometimes. But we'll put this above it, and then we'll also create our character table first. So I'll pull that, put that there, and then we'll do that, and that will make it so that it works. And then I'll pull out of my inventory one, do that, out of my character one, and rip that out like that. And I'll need to do some cleanup here so we can drop our tables in a second. Actually, I'll just do it now. So we'll go into PG admin, and then we'll drop these tables. So I believe we can just drop them by doing this. So delete, cascade, yep, delete, cascade, yep, and then delete, cascade, yep, and then that will delete those tables out of our database. So that way this gets recreated. So in order for us to actually do a proper transaction, we need to effectively start that transaction, which is what this is doing. And then we need to then actually do our work. So first things first, we're going to insert data into our transaction. Now, you see here we have user one result. Perfect. That's exactly what we want, because that's going to allow us to insert data into our database and use that user reference for this. So first things first, I'm going to create a character. I'm going to reference them. If you look at our SQL, I'm going to create a character, which is right here, and it needs to refer to a user ID. So what I'll do is I will grab this insert command, insert into characters, I believe it's characters, and then we will pass in these values. So the values for characters is the primary key, the reference to the user ID. So we'll type users ID right there, and then we'll pass in health and level. So we'll pass in health and level, and we'll say insert character query, and then we will go ahead and commit that data. So we'll say var, and really I think I could probably get away with doing this. Hold on, insert one PostgreAdapter dot execute non-query in transaction right here, and then we'll pass in this query like so. And I do need to return my ID, so that should still give me a value back, comma, enter. This is how I usually like to do it. So comma, enter, bracket, bracket, And then I'm going to go ahead and pass in my parameters. So what is my user ID? Well, my user ID is user1result, comma, and then our second one is their health. We'll say 100, comma, and then their level, which is, let's say, 10. And then we can close that transaction, and then there we go. Now it says it's requiring an if indent, so we'll just indent that one, and there we go. And that's going to effectively execute that query in a transaction for us. And now I'm going to also add in some data into the other section of the database, which is the inventory. So we'll basically just copy this, paste, insert to, execute query in transaction, insert into inventory. It goes ID type. We'll say type is 1. Then the name of it. And then what's the last one? Character ID. So we'll come down here like so. And then we don't need to return anything. We don't really need that after that. We already know what it is. And for our stuff, we'll pass in our insert1. We'll pass in for the name as sword, and then for the value of our character ID, actually for the value of our character ID, we need to use insert1, and for our type, we don't really have an enum for this, but I'll just pass in a 1, so that way we have that. And that's going to execute that query, and then we need to give ourselves a way to commit that data. So var committed data is equal to PostgreAdapter dot commit transaction, and that will actually commit that transaction. And from there, it should just work. So this is going to commit that transaction and finalize it. So now we can hit play, and in theory, if everything worked, transaction committed successfully. We did get a fail to bind. You can see here we supplied 2, but prepared statement requires 3. That's my fault. I think we might have missed something. Let's see. Unless this came back null, which is possible. Transaction bind message supplies 2. Transaction completed successfully. So it did run the transaction, but it did say the transaction failed, current transaction aborted. So the nice thing about that, you can see right here, if we have data that's failed, if we come in here and we refresh our schema, so right click, refresh, you can see characters, users. Our inventory didn't get created, so that's not a good thing. But you'll notice that inside of users, it should have data because we didn't do it in a transaction. So if we come in here, and actually I have it right here, so we'll hit play, you'll see that we have these guys here. And if you look at our characters, select star from public characters, and I hit play, you'll notice that we have nothing. And that's because our transaction failed. So it rolled all that data back and we didn't break anything. And that is the power of what transactions are for. Now, I got to see why this failed, because it says 3, 3, 3, and 3. It could be that it failed because we don't have our inventory. So let's take a look at that code here. So create inventory table, create if not exists, inventory, references, characters, and then ID, that's correct. Missing a comma, and that's the reason why it failed. So let's try this again. So we'll refresh, and we still failed our transaction, which means everything got rolled back. And also, I feel like I missed. And so if we take a look at our Postgre database, we should now have, if I refresh this, an inventory setup here with the right columns right there. So that's good, but we are having an issue with our transaction. So if we take a look, we have 1, 2, 3, 1, 2, 3, insert inventory, type name, character ID, type name, character ID. It's not returning anything. That's totally fine. I can add a semicolon there, but I don't think that's what's going to cause this to fail. But we can actually add that, because you probably should add a semicolon anyway, just because it's a good idea. But when it comes to why it's failing, I'm not fully sure. Let's see. What is my type parameter? It is an integer. Our name is a string, and our varchar is a character ID. So I'm wondering if this is not returning anything. So let's go print. We'll pass that in like so, and we'll refresh. So the insert value is -1, so that's the reason why it's failing. So the question is, non-query transaction bind supplied 2, but prepared statement requires 3. So user ID, health values, 1, 2, 3, returning ID, user result 1. Is user result 1 nothing is now the question. So let's print out our user result 1 and let's see if that's it. And let's refresh that really quick. So easy way to filter your messages, user 1. So it did come back with a value, but you'll see that this has a object. So it's not an integer that came back. So that is the reason why it's mad. So my guess is I'll have to do .id here, and that should solve our problem. Let's refresh. And it says invalid access to product or ID on array. So user result, and it has IC. So it's an array of objects. So we need to do result bracket bracket 0.id, and let's try that. There we go. And that should have successfully done it. So my fault for making that mistake, but there you go. And it says the transaction has been committed successfully. So if we go and we take a look at our PG admin here, and we come into our inventory, we select inventory and we hit play, you'll notice that he has a sword. It is connected to our character ID of 1. If we select character, like so, you'll see that we have a character ID of 1, user ID of 16, health and level. And if we take a look at our users, like so, and we hit play, you'll see we have a bunch of them, but you can see that we have a 16 user, which was the one that we actually created. Now, unfortunately, we have a bunch of extra rows here because of lots of mistakes on my part, but that is the power of what a transaction is. And the really cool part about transactions is that you can roll them back, and I give you the ability for you to actually roll them back yourselves. So let's say something fails. All you have to do is call rollback transaction. Instead of doing commit transaction, you can call PostgreSQL transaction, and that will actually roll that transaction back and uncommit all of that data. So if you ever have a thing where you're updating a bunch of data and then something fails, you can either tell it to auto rollback by doing commit transaction, and then it'll just auto rollback if it fails to commit it. Or if for some reason something doesn't pass validation, you can call rollback transaction, and it'll pull all that data back out before it commits it. And of course, you would want to call that before you call commit transaction. So just something to keep in mind. So now the question is, how can I do asynchronous queries? So asynchronous queries means that it runs in the background while you're doing stuff. And that's where these signals on my Postgre adapter come in. So you can see here, I have these different signals here that you can use. Now, when you look at the code, it's all exactly the same way as if you execute a normal query. However, it's going to call one of these signals when it's completed. I'm only going to show you one or two of them. That way you're not going to just see the exact same examples as above, but just as asynchronous. So I'm just going to show you the one, and then we'll go from there. So how you can do asynchronous queries is by coming in here and running Postgre adapter dot execute non-query async. Now, something that I forgot to explain is what an execute query versus an execute non-query is. Non-query just returns an integer, and execute query returns objects. I completely forgot to let you guys know that, but that is pretty much what that's for. Now, in my case, I'm going to do execute query async, and what I'll do is I'll come in here and I will have this run by selecting data from the database. So we'll say select star from users where level is equal to 1. And I'm just going to do this because it's a default way of doing it. I'm hard coding this. I know that you're not supposed to, but it's going to be easier for me to just kind of show you guys how this works and go from there. So now to get this to fire off, you'll see that we have a non-query completed. So if I double click that and I connect it to my database here, my database adapter, and then I'll do the same thing for non-query failed, I'll connect it as well. Then what I'll do is I'll type print, or I guess since we're doing execute query, it's actually not non-query, it's going to be query, my fault. So we'll connect that and connect query failed. And you'll see that's going to come back with results. So we'll just print results, and I'm going to go quote non-query async successful exclamation point colon quote comma results. And then we'll come in here and say non-query failed, error message, like that. Now, this shouldn't fail, but that's just so that way you can do your own debugging. And then when this runs, what it's going to do is it's going to select all of the data and come back to this signal, and it'll fire it off when it's done. So we'll hit play, and you'll see non-query successful, and it comes back with all of that user data. Now, you might be wondering, okay, but what's the point? Why do I care? Well, here's why this is useful. A asynchronous query runs in the background. So up here, we're waiting for that code to get finished before we can continue. However, here we don't care. We just execute it and walk away. So that can be really good. So for instance, if I come in here and I type print step 1, right? I copy this and I come in here, let's say step 2, copy this, and I say step 3 after the transaction, and then I say step 5 after this execute non-query, and then I come down here to non-query async successful, and I say step, I guess I said 5, so it'll be 4, because let's say we would expect that that would run right after our execute query async. If we hit play, you'll see that it happens afterwards. See that? So you can page stuff back, right? Step 5, then step 4. And the reason why is because it all executes in sequence. If I type step here, you'll see it all executes in sequence until we get to this execute query asynchronous. It'll actually go out, continue running our code, and then come back with our result. And that's huge because that allows us to continue executing our game. Let's say you want to update the user inventory when the user picks up an object, right? When you do that, you can run it asynchronous in the background and say, go add this item to their inventory, and then have them continue playing the game. If we didn't have asynchronous queries, then you would have to wait until that query finished. Sometimes queries can take, minutes to run. So it's a good idea to use asynchronous when you need something to continue executing. I foresee most of the time you will be using asynchronous quite often, which is part of the reason why it's coded in. And so at this point, you have a pretty basic understanding of how to use this query system. Now, one thing that I did not cover, which I forgot to, is let's say we want to get a user here that has an inventory item. So if we come in here and we take a look at our Postgre database and we take a look at our inventory, that's going to hook us up with a character. So you can see here, EK integer 3, right? Character integer ID of 1, which is totally fine. So that means that the character, we take a look at it and we go character, and I think it's characters with an S. We'll run that. You'll see we have an ID of 1. So we'll go ahead and select the data from this character, right, and from the user. So what I'm going to do is I'm going to pull back the user name who is associated with, it looks like 16. So if we come in here, let's do this. Select star from users. You'll see that number 16 is a test1 at Gmail. Now, this is going to be hard because you can see we have all the people have the same usernames and they're not unique, and that's a problem, but we'll burn that bridge some other day. You can see here it has an ID of 16, so we can use that to select the data. So select star from users where ID is equal to 16, and that will pull back just that one user. But here's the fun part. Select star from users where ID is 16. I'm going to do triple quotes like so, and then I'm going to left join characters on. And before we actually do this, I'm going to try running this in here. So select star from public users where ID is equal to 16. So if we run this, you'll see it's going to come back with the one user. And now if we come in here and we left join our characters on ID, comma, I guess it's going to be users, public.users.id equals public characters dot, and if I remember correctly, characters have a section in here where we can pull that back. If I take a look at our character column, it's going to be users ID. So users ID, and we'll do public dot. And if we run this, we get a failed. So we get where ID is equal to 16. So we'll need to also do public users ID. So we'll run that. Dot ID is 16. And I don't care about this order, so we'll do that. And there we go. So now we got back our character and their user information. And now I can flip this a little bit and make it work for our inventory. So we'll go public inventory, left join, characters on, and my brain is just working through this, so forgive me. Left join characters on, public.inventory.character ID is equal to public.characters.id, and then left join users on that where public user ID is equal to 16. And in theory, that should return my inventory. And there we go. So now we can pull this query. So copy it, go back in here, and then just paste it in here. And I just wanted to do it in there because it's a little bit easier for me to come up with the query when I have a way to run it. And now we can actually come in here and hit play, and you'll see that step 4 once again executes out of sync. If we do that, there is our user's information with their weapons and things like that. Now, of course, you're executing asynchronous queries, right? So you want to make sure that you have a balance of that. And that's basically how you do an asynchronous query within Godot and pulling back the data that you want. Now, of course, it's always a good idea to kind of limit your data scope as much as possible, and you're going to need to do a lot of processing logic inside of here if you want to handle different types of data. Remember, this is only going to execute on any asynchronous query that you do, so it's just something to keep in mind. So at this point, you have a pretty good understanding of how to use this plugin. Now, one thing that I didn't cover is connection error. Basically, if you have a connection error, let's connect that really quick. You will get an error message. So you could say print connection error and then pass in the value here like so. And then if you were to come up here and mess with your port, let's say, and change this from a 3 to a 2, and you refresh it, you'll see that we'll get a connection error in a bit. It's going to take a while, but it'll print out here where it failed. And that's basically what that connection error is for. And then transaction committed, failed, rolled back, those all fire off when something like that happens. So if you have a transaction that commits and successfully does, this will run. If you have a failed one, it will run with an error message. If you roll it back, it will run that little bit. And then once again, if a transaction starts, it will do that there. So at this point, you have a pretty basic understanding of how this plugin works. So if you like this video, go ahead and hit that like button. And hey, you know, if you dislike this video, go ahead and hit that dislike button because I am here to make content for you guys. This video was a viewer suggested video, and the entire plugin was a viewer suggested plugin. So please, if you have any suggestions, please leave them in the comment below or jump on my GitHub. Links in the description for that. And I'll be more than happy to take a look at it. I'm currently working on a rhythm game because somebody recommended I should. I'm going to start a shooting tutorial hopefully soon, and I am also looking at doing a Diablo-like game as well. So please, let me know if you guys have suggestions. I'm always up to learning something new and to exploring something. And hey, if you guys have any questions or comments, leave them in the comments below or jump on my Discord. Link is in the description for that. And anybody there will be more than happy to help you out. But that is all I have for you guys today. So thank you so much again for watching. And I'll see you all next time. Thanks.